question addresses the compliance of a transformer secondary conductor installation with the National Electrical Code, specifically Section 240.21.C.6. This section pertains to the overcurrent protection of transformer secondary conductors where the overcurrent protective device is not located at the point where the secondary conductors receive their supply. The specific scenario involves a 480 volts to 120/208 volts transformer situated on a mezzanine without a permanent access ladder. The primary overcurrent protection is provided by a 250 amps fuse. The secondary conductors consist of two sets of four 250 kc mil copper THHN conductors. The secondary overcurrent device is a 600 amp circuit breaker located in a panel board. The conductors are installed in conduit. The question is whether this configuration complies with the 25-foot tap rule outlined in 240.21.C.6, and if not, what modifications would be necessary to achieve compliance. The analysis hinges on the requirements stipulated in NEC section 240.21.C.6. This section allows for transformer secondary conductors to be run without overcurrent protection at their source, provided certain conditions are met. These conditions typically involve limitations on the conductor length and the overcurrent protection at the termination point of the conductors. Firstly, the transformer secondary conductors must not be more than 25 feet long. This is a critical dimension in determining compliance. Secondly, the circuit breaker in the panel board, serving as the overcurrent protective device for the secondary conductors, must be rated not more than the allowable ampacity of the conductors. In this specific case, the circuit breaker is rated at 600 amps. Thirdly, the conductors must be installed in conduit. Conduit provides physical protection to the conductors, reducing the risk of damage and potential faults. The conductors in question are two sets of four 250 kc mil copper THHN conductors. To determine if the 600 amps overcurrent device is appropriate, we need to determine the ampacity of these conductors. According to NEC table 310.16, the ampacity of a 250 kc mil copper THHN conductor is 255 amps, assuming it is rated for 75 degrees Celsius termination temperature. Since there are 4 conductors per phase, the total ampacity per phase is 4 times 255 amps, which equals 1020 amps. Because there are 2 sets of these conductors, the total ampacity is 2 times 1020 amps, which equals 2040 amps. Now, we must examine the specific requirements outlined in 240.21.C.6. This section allows for the overcurrent protection to be located at the termination point of the conductors, provided certain conditions are met. One crucial aspect is whether the overcurrent device is readily accessible. Readily accessible is defined in Article 100 of the NEC as capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to actions such as to use tools, to climb over or remove obstacles, or to resort to portable ladders, and so forth. The fact that the transformer is located on a mezzanine without a permanent access ladder raises a concern about the accessibility of any overcurrent device located at the transformer. The NEC also addresses the accessibility of overcurrent devices for qualified persons. Qualified persons are individuals who have the skills and knowledge related to the construction and operation of the electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. The NEC recognizes that certain equipment may not be readily accessible to the general public but may be accessible to qualified persons. If the overcurrent device at the transformer is not readily accessible due to the lack of a permanent ladder, the code allows for an alternative. The alternative is that the overcurrent device be accessible to qualified persons. Given that the circuit breaker is located in a panel board, it is generally considered accessible to qualified persons. Electricians, maintenance personnel, and other trained individuals can access the panel board for inspection, maintenance, and troubleshooting. Therefore, the location of the 600 amp circuit breaker in the panel board satisfies the requirement for accessibility to qualified persons. Furthermore, the 600 amps overcurrent device does not exceed the calculated ampacity of the secondary conductors. The conductors have a total ampacity of 2040 amps, which far exceeds the rating of the overcurrent device. This ensures that the conductors are adequately protected against overcurrent conditions. In summary, the installation meets the requirements of 240.21.C.6, provided the following conditions are met: the transformer secondary conductors are not more than 25 feet long, the circuit breaker in the panel board is rated not more than 600 amps, the conductors are installed in conduit, the 600 amps breaker is located in a panel board, making it accessible to qualified personnel. If it is deemed necessary to have an overcurrent device at the transformer itself, it would need to be located at a readily accessible location. This could involve installing a dedicated panel board in the mezzanine with a permanent access ladder to ensure that the overcurrent device is readily accessible to qualified persons. However, based on the initial conditions, the existing installation complies with the NEC as long as the aforementioned criteria are met. It is important to emphasize the significance of qualified persons having access to the electrical equipment. The NEC recognizes that qualified persons possess the necessary training and expertise to safely interact with electrical systems. By ensuring that the overcurrent device is accessible to qualified persons, the electrical system can be properly maintained and operated, reducing the risk of electrical hazards. In addition to the above analysis, it's crucial to consider other factors that could impact the compliance of the installation with the NEC. This includes the proper installation and termination of the conductors, the grounding and bonding of the electrical system, and the overall condition of the electrical equipment. It's also important to note that the NEC is updated periodically, and it's the responsibility of the installer and the inspector to ensure that the installation complies with the latest edition of the code. The NEC provides specific guidelines for the installation and protection of electrical conductors. These guidelines are designed to minimize the risk of electrical hazards, such as fires and electric shock. By adhering to these guidelines, the electrical system can be safely and reliably operated. The length limitation of 25 feet for the secondary conductors is a critical aspect of 240.21.C.6. This length limitation is intended to minimize the potential for faults to occur in the conductors. The longer the conductors, the greater the risk of damage or insulation breakdown. By limiting the length of the conductors, the NEC reduces the potential for such faults to occur. The requirement that the conductors be installed in conduit also contributes to the safety of the electrical system. Conduit provides physical protection to the conductors, shielding them from damage caused by impact, abrasion, and other environmental factors. By installing the conductors in conduit, the NEC increases the reliability and the longevity of the electrical system. The overcurrent protection at the termination point of the conductors is another critical safety feature. The overcurrent device is designed to trip and interrupt the flow of electricity in the event of an overcurrent condition, such as a short circuit or an overload. By providing overcurrent protection, the NEC prevents damage to the conductors and equipment and minimizes the risk of electrical fires. The accessibility of the overcurrent device to qualified persons is essential for the proper maintenance and operation of the electrical system. Qualified persons are trained to recognize and address potential electrical hazards. By providing qualified persons with access to the overcurrent device, the NEC ensures that the electrical system is properly inspected and maintained. In summary, the installation described in the question meets the requirements of 240.21.C.6, provided that the conditions outlined above are met. These conditions include the length limitation of the secondary conductors, the rating of the overcurrent device, the installation of the conductors in conduit, and the accessibility of the overcurrent device to qualified persons. By complying with these requirements, the electrical system can be safely and reliably operated, minimizing the risk of electrical hazards. It's important to note that this analysis is based on the information provided in the question. If there are any other factors that could impact the compliance of the installation with the NEC, it's the responsibility of the installer and the inspector to address those factors. The NEC is a comprehensive set of guidelines for the installation and protection of electrical systems. By adhering to these guidelines, the electrical system can be safely and reliably operated, protecting people and property from electrical hazards. Therefore, yes, based on the provided details, this meets the requirements of 240.21.C.6. If the transformer secondary conductors are not more than 25 feet long, the circuit breaker in the panel board is rated not more than 600 amps, and the conductors are installed in conduit. The rationale is that 240.21.C.6 states that the overcurrent device protecting conductors connected to the secondary of a transformer shall be located within 10 feet of the transformer or shall be accessible to qualified persons. In this case, the circuit breaker in the panel board is more than 10 feet from the transformer, but it is considered accessible to qualified persons because it is in a panel board. Therefore, the conductors meet the requirements of 240.21.C.6. An alternative option is if it is deemed necessary to have an overcurrent device at the transformer itself, it would need to be located in a readily accessible location such as a dedicated panel board in the mezzanine. This would ensure that the overcurrent device is readily accessible to qualified persons, or an overcurrent protection device at the transformer that is within 10 feet.